Hello, good morning. I would like to welcome you all the delegates and participants of the Roundup event of EU's Co-Versatile project. My name is Gabor and I will be your moderator for the whole event. Please say hi in the chat in the right of the page, and please also state where are you from, your country and your organization. You can navigate around the event by clicking on the icons in the navigator bar. If you are from a desktop, then you will see a navigation bar on the left side of the desktop or the screen. And if you are from a phone or tablet, you will see that on the bottom of the screen. When you are in the reception area, you can click the schedule tab to view the full agenda. You can also scroll down the page and you will see the supporters of the event and the speakers list. I personally represent one of the organizers of the Co-Versatile project. We are a Horizon 2020 project supported by the European Commission. The project started 2 years ago, just after the breakout of the COVID-19 pandemic. Our aim is to strengthen the adaptation capability, the resilience, and the flexibility of the European manufacturing sector. I believe that this goal became even more important since the beginning of the pandemic, because the turbulent times are not over. The turbulent times, as it looks like, are staying and is with us and will stay for the upcoming months or years. We do work with a number of SMEs from the manufacturing sector. We do work with many SMEs from the healthcare sector, and we do see multiple challenges for the companies. One is the disruption of the supply chains. So each of the SMEs are suffering with the lack of raw materials and components, shortages of different materials. They also face another challenge from the side of their clients, that the clients are continuously adapting their needs and changing the production schedule. And this means a completely new challenge for the manufacturing SMEs. Because they also need to very quickly repurpose and adapt their manufacturing processes to the new needs. And on the other hand, there is another issue which is quite common in Europe, and this is the lack of workforce, the lack of educated and well-trained skilled workforce. And this is usually both, all four aspects are with us in the past months, and it looks like it will stay. So this is a completely new environment for the SMEs, and we at the Co-Versatile project try to address this. The Co-Versatile project consists of more than 20 expert entities which team up and united their expertise to answer these challenges. Our objective is to help the manufacturing SMEs in the medical sector to develop adaptive and resilient production and supply chain methods and solutions, and to help them to urgently able to adapt to any upcoming new needs. And today we will see the results of those 2 years journey. First, let me tell you some words about our agenda. Yes, and if we go now to the agenda slide, then today the event consists of 2 parts. Thank you. Now we are in the first section of the event, which will last until approx 1 p.m. CST. These are mainly presentations and introductions of the results of Co-Versatile project. In case you have any questions, you can anytime ask in the chat window on the right-hand side of the screen. So today, after this few welcoming and introductory words. I will give the floor to Dr. Lovash, to Dr. Robert Lovash, who is Deputy Director at the famous SZTAKI Institute. SZTAKI Institute is a major research institute on the field of computer sciences and automation. And SZTAKI is the coordinator of co-versatile project. After that, we will hear three specific results of our pilot projects or manufacturing settings, as we call it in the project. First, we will hear the face mask about face mask production from Dr. Matthias Wangenheim, who is assistant director at the Leibniz University of Hannover. Afterwards, we will hear about the ventilators, and ventilators were in high demand, especially in the very beginning of the pandemic period, but are still in high demand up to now. And the CTO Ben van den Elshout will talk of the DEMCON, will talk about their experience with respiratory systems. And as third, we will hear the electrostatic spray segment. Antonio Salis, who is senior director, senior R&D project manager at engineering, and Jan Llopart, who is a sales manager at Tecnostatic. They will present how electrostatic spraying production can be ramped up. Afterwards, we will have a short break, and then Sebastian Pena Serna will present as the digital technopole. Sebastian is founder of clesgo, a company specialized on democratizing and promoting digital manufacturing. And Sebastian will talk us how the digital technopole can be used for also other SMEs to increase their resilience, to increase their adaptation capabilities and flexibility. And then finally, a little bit around 12:30, I will have a quick closing words. But with this, the event will not finish, because from 2 to 5, we will have the Expo area. And the Expo area you find in the Hopin system. You can register and ask for separate meetings. And also, if you have any questions, any technical issues, just please type into the comments side, and we will help you. On top of this, in the reception area, you can also find a help desk where you can receive further support, how to join or how to manage your journey throughout the Hopin platform. Please feel free to use the chat box to any time, and the speakers will not be able to answer your questions right now, but we monitor continuously the questions that you pose in the comment side, and those will be answered at the end of each segment. I will continuously monitor it, and will be making that questions at the end of the segments. So with this introduction, I suggest let's go on and let's start the show. So the first speaker will be Dr. Robert Lovash, who I mentioned. He is Deputy Director at SZTAKI, and he is coordinator and master of the co-versatile project from the very beginning. Robert is a habilitated associate professor and the founder of the Institute for Cyber-Physical Systems at the John von Neumann Faculty of Informatics at the Óbuda University. He has been elected as a member of the Committee of Information Science at the Hungarian Academy of Sciences and received János Borai Research Scholarship. Robert has more than 20 years of research and development experience in the wide range of application fields of distributed and parallel systems. He has gained experience to work with various global, European, and national collaborations both with academic institutions, universities, enterprises, focusing on computational chemistry, numerical, methodological modeling, bioinformatics, agriculture, connected cars, Industry 4.0, so a number of fields. And really, he is a professional with a very wide range of experience. He coordinated already 2 e-infrastructure projects in the EU's 7th Framework Program to build computing science services for research communities. In the national agrodat.edu project, he led the big data research platform activities, and he currently acts as the coordinator of CoVersatile, and he is also a director of the cloud services for the Hungarian academic sector. His latest research achievements contribute to the recently launched Artificial Intelligence and Autonomous System National Laboratories. So, with these introductory words, I would like to give the floor to Robert, and I would like to ask him to start his presentation. And please welcome Robert. The stage is yours.
Thank you, Gabor, for the introduction, and good morning. Also, I would like to welcome the participants on behalf of the CoVersatile Consortium. So let's go back in time, spring of the year 2020, and I would like to ask my colleagues to share the presentation. Thank you. And on the next slide, you can see that, and just to explain the background of our activities, COVID-19 as a global health crisis caused very serious disruptions in supply chains, as Gabor mentioned. At the same time, the unprecedented demand for personal protective equipment, as you can see in the Google Trend Analysis diagram in the right-hand side, required a really rapid industrial response and the production at short notice. So in most European countries and global as well, government ordered to wear face masks that very quickly became a proven and simple way to somehow prevent the virus spread and protect citizens. So we had an extraordinary situation around the world. Everybody struggled with a shortage of masks, ventilators, disrupted supply chains, and we were witnesses of really chaotic situations. So, but if you take a look at the diagram, we are still witnesses of newer and newer crisis situations that even had caused a shortage of, let's say, vegetable cooking oil recently in the UK due to the Ukrainian situation. So let me introduce some projects themselves coping with such challenges in the next slide. So in my opinion, the European Commission reacted very fast to this pandemic situation and opened an extraordinary Horizon 2020 call in May 2020 with an extremely tight deadline and more than 120 million euro budget. And we had only 3 weeks to build the consortium and prepare the project proposal. 4 out of the 23 winner projects, CoVersatile, Eureka, Reservist, and Impure, are formed a kind of cluster for repurposing of manufacturing for vital medical supplies and equipment. So they might be considered as our sister or brother projects. And the next slide, I would like to highlight the most important achievements of our project in 3 distinct categories. The first one is about the speed of the virus spread. Immediately moved to the safety and related infection prevention measures to the top of the agenda. So in many countries, including Hungary and other European countries. And to prepare Europe for managing pandemics and virus spread, a team of CTO partners developed and scale up efficiently the production of disinfection spraying system using the components of the regional and European supplier networks. So the production capacity has increased by 30%, so we reached our goal. On the other hand, we also offer manufacturing companies a replicable method for fast repurposing of their production lines for manufacturing different personal protective equipment, such as FFP2 silicone mask in really high volumes on short notice. So we were able to increase the production capacity by 400%, increasing and reaching the initial goal, which was only 100%. And as a third one, the project scope also included the analysis of and research of ventilator supply chains to address the challenges of availability of its part components, focusing on somehow boosting the resilience. So the production capacity has increased by a really incredible number, 10 times. So we reached the goal here as well. So without diving into the details now, you will to learn more about this in the upcoming presentations from my colleagues. But to understand better the situation, let's see the background. Next slide, please. You may see the key figures of our project and a few core partners, including SMEs, universities, research institutes, digital innovation hubs, and consulting companies with common background and joint activities in various Horizon 2020 and other European projects, decided to come up with the project idea called Versatile. Actually, it was leveraging on our solid expertise in manufacturing, simulations, in my case, personally in IT, certifications, training, a lot of other related topics. So more and more new consortium members had been invited to get a really complementary knowledge set necessary for fine-tuning and implementing our project plan. So finally, we had 21 members, as Gabor mentioned in the introductory, from different countries like Austria, Germany, Hungary, Israel, Italy, the Netherlands, Spain, Switzerland, and also the UK. As also Gabor mentioned, I used to coordinate 2 other European projects in Framework Program 7, and our research institute, SZTAKI, coordinated altogether more than 15 European projects. So just to make this long story short, taking the leadership was really a safe forward and obvious decision from me, from the institute, to have the society, companies, and healthcare sector and other stakeholders in fighting with COVID-19. Please note that the project was only 2 years long. This is the last month of the project, so we have this roundup event now. And we could start the work even from D0 when we submitted the project proposal. So it is also unusual in such project. It was really evolved by this extraordinary Horizon 2020 call. And concerning our concept, next slide, please. You can see that the Versatile project is built upon a range of innovative and research industry-driven initiatives. And the main aim is to deliver demonstrators of a flexible, very challenging 48-hour industrial response capacity at scale to cope with the sudden spikes in the demand of strategic products, medical products, and also for qualification of or release of manufacturing settings. So the overall project concept is outlined on this figure, and you can recognize 4 key lines of actions represented in different colors. Let's start with the technological part. This is the bluish. So a group of core partners support and deploy the technologies and the services needed for repurposing of selected manufacturing settings spanning several European countries and 5 vital medical supplies and equipment, as you can see in the left-hand side, like a reusable silicone mask, electrostatic disinfection, ramp up production of ventilators, and so on. So the technology, so the targeted areas, you can see there are the manufacturing simulations, like based on HPC or cloud resources, to increase the flexibility and adaptation capacity of manufacturing settings that needed to repurpose the production line. Another one you can see also on the figure of supply network simulation and risk management related activities to respond to the disruption of supply chains. The third one is about automation and system integration technologies to assure that the dependence of human workforce is absolutely minimal, and setup and ramp up time is reduced dramatically. These are required for production line certification, calibration, accreditation. And the certificate, and also you can see that the certification, training, and qualification, and also are in the scope of the project. And in this case, the operators through virtual reality or augmented reality, human-machine interface modeling, and other automated assessment are also targeted to assure that the personnel of the repurposed production lines is provided with the right knowledge and to operate with proper safety and quality standards. So now it's also related a bit to regulatory aspect, and this is you can see also with another purple color. And here we can see, given the industrial domain in which covered project is operating, as well as the external nature of this initiative, the particular care is dedicated to regulatory issues, including product regulation, process validation, training, ethics, and data management. Okay, concerning the operational aspects, this is again highlighted in a different colors, about greenish. In this framework, really a constant process of, so we look for communicating, assessing, comparing the repurposed manufacturing setting with their business as usual situation and with the really wider EU manufacturing industry. And the goal here is to assure that assure the sustainability, reparability, and scalability. And this is must be delivered to these manufacturing settings, and also to the wider European manufacturing industry. And this activity is connected by, I think, manufacturing. And this event is also a part of these activities. Concerning the platform setup, the goal was supporting the manufacturing industry and interested parties, particularly SMEs, and also being the also beyond the project manufacturing settings. The key expected results delivered through so-called digital technopole, and this could be considered a single entry point. And this is a sort of meta platform that allows the European manufacturing industry to access the services. And this will be introduced with more details in Sebastian's presentation later. Next slide, please. Here you can see the way how we worked in the project, how we delivered our results. So concerning our methodology, Covertech follows a really radically different approach with respect to our regular European projects, but for example, I was coordinated earlier. Our methodology leverages on some key elements imported from the lean startup methodology. So the development is iterative and broken down into several cycles, as you can see on the slide. The phases are build, measure, and learn, and they properly adapted to respond to the project needs. So we have a build phase, and this involves competence centers, manufacturing settings partners working together to deliver the minimum viable product for demonstrators. So this is the bare minimum product that can be built in order to test several assumptions and start delivering results as quickly as possible. Since it was an important requirement in the project. And within the measure phase, competence centers and manufacturing centers partners are working together to analyze, organize, and present the data. So these are produced with the help of the minimum viable product, and also assess the process that was made. And finally, the learn phase based on measurements, and actually deals with choices for following iterations, and also these choices and decisions can be something like about do we need additional development with certain competence centers or possibly move to other aspects, and so on. And next slide, you can see that these challenges, these what we faced during this development, what were that kind of pillars which are really necessary to care about. And to be honest, these challenges are not made only for the pandemic situation, but also the current crisis as well. So you can see that like adapting manufacturing processes for upscaling of production or product and process application for rapid manufacturing, reconfigure and re-evaluate industrial supply chains, and also very important for startups and the future of work. So these 4 pillars have to be answered together, and have to be provided together to answer this respond this crisis. Okay, next slide, please. These are some of the achievements, and today my colleagues will describe these achievements with more details. I just want to really highlight a few of them. For example, in case of machine for mass production and reusable silicone mask, we significantly improved the resilience, and also you can see on the slide that so the manufacturing time was significantly reduced for a large amount of FFP and FFP3, FF2 and FFC masks. Also, as another achievement concerning the SZTAKI disinfection system, we were able to increase performance by 70%. Also, you can see that in case of resilience automation for manufacturing topic, we also are able to achieve to double assembly capacity. And the last one, what I would like to mention here is was very, let's say, very significant improvement, and this is about ramp up production of ventilators. So you will be able to learn more about this during the upcoming sessions. And the last on the last slide, next slide, please. We can see that the digital technopole. This is on my last slide because it's really the heart of the COVID system. We have the digital technopole, and just let me show very briefly see the ecosystem through the diagram. So it is possible to identify the digital stakeholders here, digital technopole stakeholders here, and I'm going to highlight only some of the major stakeholders, hoping that you may recognize yourself in one of these categories, like consultants or digital innovation hubs, manufacturing SMEs, and so on. And in the right-hand side, a wide variety of services are also highlighted as an appetizer, like software solutions, training courses, and digitalized processes. Also, my colleagues will guide through the features and main concept of digital technopole, and this one can be the way how you can access our results, and how you can be a part of our activities. So next slide, please. I would like to thank you for your attention, and also I would like to wish successful conference meetings and also I would like to encourage you to visit the Expo site as well, where you can have one-to-one meetings as well. So thank you for your interest. Thank you.
Thank you very much, Robert, for this inspiring introductory presentation. And I would like to encourage all the participants to book a slot with Robert in the Expo area. He is one of the persons who might be available in case you wish to have any discussion. And I believe it was very interesting to hear about the build, measure, and learn methodology, what is known from the startup ecosystem, and to use this for a European project, which is usually a definitely different area. So thanks again, Robert. And now I would like to move on and get a deep dive into the results of the project, the face mask segment first. And about the face masks, Robert introduced that there was an enormous 400% increase in the demand. 400% is a major difference, and I would like to introduce our first speaker, Dr. Matthias Wangenheim, from the Leibniz University of Hannover, Germany, who will explain this challenge and talk about how they were able to cope with this increased demand. Since 2013, Matthias is assistant director at the Institute of Dynamics and Vibration Research at Leibniz University in Hannover, Germany. He is leading a research group in the field of friction and tribology. He has been involved in several international Horizon 2020 and Horizon Europe R&D projects, and as well as numerous bilateral product-oriented industrial collaboration. Prior to his academic career, he was working for companies in the aerospace industry as systems and innovation managers and advanced product engineer. Matthias holds a PhD degree in mechanical engineering. His thesis addresses friction and wear prediction of pneumatic industrial seals. And with these introductory words, I would like to give the floor to Matthias to talk about face mask production, to talk about how he and his team was able to cope with the significantly increased demand. So Matthias, the stage is yours.
Yeah, thank you very much, Gabor, for the introduction. Can you put up my slides, please? Okay. Yeah, one of the outcomes of CoVersatile is a manufacturing kit for reusable silicone face masks. This was developed within the last 2 years by a subgroup of our large team. And I want to go through the development steps and the contents of this manufacturing kit. The idea is that we enable rubber manufacturers all over Europe to produce silicone or reusable silicone face masks. Let's start with an outline. This silicone face mask manufacturing kit consists of several steps. The first is that I will go through the development and the launch of these face masks together with you. We started quite early with a rapid prototyping phase to get a better idea of the design and the touch and feel of our mask. We transferred this prototyping results into a real product, and as it is a molded silicone rubber mask into the mold. I will go into detail with that. And we always kept in our mind an easy scale up of the production. So depending on the demand for face masks, we think we found a nice solution to respond on changing demand. We will support other manufacturing sites to reconfigure their production lines for face masks. We support them in planning their supply chain and, if needed, for the company and product certification, especially in terms of medical certification of the company. First of all, we took advantage of our large intersectoral and interdisciplinary team. So we were involving 3 SMEs, manufacturing SMEs. First of all, a mold maker based in Italy, ORP Stampi. We have the manufacturer of these molded parts, so the company which uses the molds from ORP. This is in our project SKM Aeronautics from Israel. And we had in our team ML Engraving, an SME who specialized in laser engraving of molds. This is important if you consider wearing a rubber face mask on your face all the day, then it helps if we have a nice texture. They got support in terms of R&D for process simulation, so molding simulation tasks by ITA Innova in Spain, and the rapid prototyping phase was done by ourselves here in University of Hannover in Germany. Furthermore, we got, in terms of business consultancy support by a wider team. I will go into more detail later. We had help with the certification issues from SUPSI in Switzerland. We had training documentation for enabling other manufacturing partners to build our mask by HSMI from Great Britain. The supply chain analysis was led by Fraunhofer IML, and risk awareness and risk analysis was performed by IE Business School from Spain. Let's dive deep into the product. So we wanted to create a mask or a new mask, and if you ask potential customers what is important for a mask, then first of all you will hear high wearing comfort. High wearing comfort comes together with a good texture. I mentioned that already. And if we want to be sustainable or reusable, we need to have exchangeable filters, yeah, for different filter grades, but also those cannot really be reused. There we have to use disposable filters. Transparency was something mentioned quite often. So for being able to see the lips moving, for example, this reusable means that it has to be washable. Another term which was mentioned quite often is that glasses don't get foggy when you breathe out, especially in winter. You know that this happens quite often when you wear a face mask. And the ease of breathing, of course, is important. If you wear a rubber mask on your face, then still you need to be able to breathe as easy as with a non-woven mask, which you all know very well. So first of all, we had to choose a material, and we went for silicon elastomers, HCR grade. So this is solid silicon. We would not go for liquid silicon. I will explain that later. There are medical grades available on the market by several suppliers. They are very easy to process and they are non-toxic. Yeah, this is important if you look for medical certification, and it is important also for supply chain considerations that these basic compounds, rubber compounds, are available on the market. Next step is the filter. The filter in our solution will be attached to the rubber mask. There we have 2 solutions available in the market. One is the cloth solution and one is non-woven filters. Both are available in grades which are relevant for us, so N95 or FFP2 respectively. Again here, we had to take into consideration supply chain. The supply chain. Both are available very easily also from European distributors. For certification needs, both are certified and need to be certified with the mask as a whole product in a later stage, but we have to take this into consideration when choosing our filter material and also when choosing the supplier. Transparency was one of the key ideas behind our mask production. We went for rapid prototyping based on a 3D printer with the SLA, so stereolithography technology in our lab. So we printed the full rubber mask in the first design to try to fit it to different phases to see how it feels. If the structure is stable when you breathe in, it should not collapse. And we also printed different microtextures to see how it feels, especially on the ceiling lip, on your face, and also on the laces behind the ears. At the same time, ML engraving started to texture different flat samples at first to get a velvety texture, or as velvety as possible. Later, in a later stage, when you see the complex geometry of the mask, you have to consider that this is a free-form surface which has to be textured all from every position. They were using nanosecond or picosecond laser technology to apply this negative of the texture on the mold. Yeah, and we textured all the parts which are in direct contact with the skin to get as comfortable as possible a feeling when you wear the mask for a longer time. So for the mask design, when we summarized that, we were selecting materials. We went for the HCR silicon rubber compounds. We defined a texture, velvet texture for wearing comfort. We went for an adjustable strap so that, or adjustable laces so that it can be fit to different face sizes. We ensured a proper filtering through our cloth or non-woven filters. And of course, at the same time, we need to seal all around the face that the air which you breathe in or breathe out goes through the filter and not passes the mask somewhere else. This proper sealing also has the big advantage that your glasses do not fog. And coming back to certification considerations, it needs to be fail-safe in use. You only get your product certified when you will wear it properly and the use is fail-safe and easy. Now, when we finished the mask design, the next is to apply or to build a mold, to design and build a mold to produce our masks. And one of the considerations there was that we had to fit our mold to a very common vulcanization process, which you find at different or many rubber manufacturers all over Europe. And this typically is a press with an area of 500 by 500 square millimeters. And this also defines the number of cavities, so the number of molds, masks which we can mold simultaneously. In this press size, it is limited to 2. So we offer 1 or 2 cavity molds. If you look on the right, the green part, it's an insert which we use for demold our mask. So you do not have to manually demold the part, but it can be automatically demolded. And this is the part which is textured. So it's quite easy to only send these small insert to our texturing partner ML. You do not have to send the whole mold. We optimized the injection inlets so that we have an optimized material flow and as fast as possible material flow so that we can reduce the duration of the molding cycles. And what is also important, this type of mold is able to cope with all types of solid rubbers. So if there is a shortage in your favorite medical grade, you can use other rubber types, for example, food grade, which is also still okay to wear on your face. We went for a transfer injection solution. This is a relatively new technology that we transfer your molding press, traditional molding press, into an injection machine. This has the very big advantage that we save material because we have no deflashing. This part was designed by ORP Stumpy, our mold maker, together with SKM, the molding SME. Here, upscaling considerations were most important for us, so we need a mold which fits in as many presses as possible, and the process as is has to be as robust as possible and fail-safe. Concerning the molding process itself, we started to compile training documents so that we can transfer our technology to other molding manufacturers. This considers material handling from material incoming inspections to all overall QA procedures before and after the molding. The molding process itself, including molding parameters like temperature cycles, like pressure cycles. Post-curing is very important for medical products. They need to be fully vulcanized, fully off-gassed. So this is part of our documentation, and we made considerations on the traceability of each product, which is important for obtaining the medical certification. Together with our partner HSSMI, we compiled a training and knowledge transfer package, which is based basically on a 3D PDF documentation where you interactively can get all information which you need. In the upscaling and reconfiguration activities, we got support mainly from 4 different partners. We performed a risk analysis considering production risk, supply chain risks, market risks, and the risk of certification, which you might need. There we got support from IE Business School. The supply chain of our product was done, analyzed by Fraunhofer IML. So we included tier 1 and 2 suppliers, transportation times, market demands, and the ability of our production line to produce a certain number of masks. We got help with the training documentation by HSSMI, and certification issues were discussed and analyzed by SUPSI. Now, coming back to the manufacturing kit, we offer a full kit which contains 1 or 2 cavity serial mold. The serial mold on the right-hand side you can see in our production line, where we produce 2 masks of different size. The left-hand side is for adults, and the right mask, or the one in the background, that's for children. This was a combined activity by ML, University of Hannover, ITA, Innova, SKM, and ORP. We have interactive training manuals for the entire manufacturing process, so you can follow the material through the factory virtually with the thanks to the help of HSMI, from the raw material income until the delivery of complete masks or packaging and delivery. We have an interactive support or provide an interactive support on medical certification. Thanks to SUPSI, this is part or integrated in the digital Technopole, which we will see this afternoon. We have an online supply chain analysis tool provided by Fraunhofer IML, where you can analyze your own supply chain. And we have a guided risk analysis service provided by IE Business School to analyze your production, your supply chain, and market demands, and so on. This altogether is offered as a manufacturing kit if you want to start producing face masks on your own. That's it from my side. Thank you very much for your interest.
Thank you, Matthias, for this interesting presentation. And we do have one question from the audience, that you mentioned that you were working with an interdisciplinary and intersectoral team. And I would like to ask how you were able to manage this and how the communication was managed among this team. Because I guess that the COVID pandemic also made some extra challenges in terms of traveling and in terms of personal meetings. And how were you able to cope with this?
Actually, there were only 2 personal meetings throughout 2 years. It was indeed possible to work together with this in virtual sessions. And also product design can be done virtually today. There are quite nice tools available. What helped us is the quite strict project organization with the build, measure, learn cycles, which we introduced in the beginning, because we had to apply this also in our smaller team, and there was a clear timeline based on these cycles, which could be quite easily and I think successfully applied to our product.
Thank you. Very interesting, and I think that is one of the main learnings also for me personally from the Coversatile project, that many things are possible currently online. So many things that we believe prior that we need to meet, now we could somehow replace it with online communication. Of course, different methodologies have to be used. Thank you so much, Matthias. And our next topic is ventilator, and ventilators are vital equipments. They became very important during the pandemic, and this resulted in a spike in demand. Ben van der Elshout will introduce the result of our manufacturing settings, and he will talk about his experience, how to ramp up ventilator productions by 10 times, as mentioned by Robert in the beginning. And again, here, when I said by the face mask 400% increase, now it's 10 times here. So this is, I think, a significantly different challenge. And Ben will talk about how to address this. Ben has been for 2 years the Chief Technology Officer of DEMCON Macawi, and he is the technical owner and the manager of the Demcare product, which was developed during the COVID period. And Ben was responsible for all the developments within Macawi. And now with this introduction, I would like to give the floor to Ben to explain how ventilator production was ramped up.
Gabor, thanks for your introduction. Yeah, as Gabor said, my name is Ben van der Elshout, and since 2 years I'm the CTO of DEMCON Macawi. And in the COVID period, I was indeed responsible for ramping up the production here and developing the complete Demcare ventilation system. Can you put out my slides, please? Brilliant. I want to give you a short introduction in DEMCON and Macawi because I think it's pretty important why we are able to ramp up production that fast. DEMCON started as an engineering company in 1993, so it's almost 30 years ago, with two engineers coming from a technical university here, and they started the company. In the meanwhile, and these numbers are a little bit outdated already, we are an engineering company with more than 1,000 employees, and we are in principle a system designer, and an R&D house. And within the R&D house, we are operating in the medical field, in the high-tech field, in developing system as contract R&D, typically for our customers. And as DEMCON Macawi, maybe that's... I will first tell you a little bit about the DEMCON activities, where we start. Whoa. Go on back. The DEMCON activities are in general, we start with, ideas from scratch. So a customer can come to us with some ideas, how his product would look like in sketches, like you see here in the left corner. And we can go up to a complete production for a customer. So we go from initial idea up to a prototype, or concept development, or whatever is needed, and then develop that up to a complete device in which we can also pick up production, as we have our own assembly facilities in the eastern part of the Netherlands. So we have practically everything available within the DEMCON group to support a customer from a creative idea up to a complete product and the production of that. And we are organized as such that we also have a couple of daughter companies, which we typically call our own product companies. And DEMCON Macawi is one of such own product companies. And Macawi is responsible for ventilation technology. We developed that already for more than 10 years. And in that period, we developed a ventilation module, which is like a shoebox size device. We sell it worldwide to customers, and our customer is responsible for integrating that product into a complete ventilation device. And practically, that's also what we did in the COVID ramp-up situation, that we started with our ventilation module, which is a full functional ventilation module and capable of respiratory care for a patient, and created a complete device out of that. I have a short movie to present to you, which shows a little bit in an overview what we did in that period.
Virus is having a major impact on our society, and everyone can contribute to flattening the curve as much as possible to ensure our healthcare system is not overwhelmed. A major challenge, however, is to equip hospitals as quickly as possible with ventilators for those who desperately need care. DEMCON develops and produces modules which form the heart of these machines. We have significantly stepped up production to supply manufacturers of ventilators all over the world with these modules. In addition, we have taken up the challenge to develop and build a simple, complete ventilation system based on our existing modules and years of experience. We are proud to have realized the Demcare ventilator, a new system created on a vastly accelerated timescale to meet the surging demand for these systems. With great commitment from our colleagues and heartwarming help from our partners, suppliers, and government, we have the opportunity to contribute to the global fight against this crisis.
So I think this gives you an overview of what happens, or what we are doing and how we developed the system. Well, let's take you along the storyline of the Demcare development. This all happened in 2020 March. So we started at a certain point with some lines between the government and DEMCON to talk about the whole ramp up and the availability of ventilation devices. And we started we call it day -3 because it was before the formal quotation was an order was placed, to have some meetings on the project. And we started to sketch in those first days a little bit how should such a system look like, and you see those pictures in the presentation. So we created a simple box where our module was placed in, and it was also at that moment we needed to think about availability of equipment, availability of materials and components we need. So the complete design and development of the Demcare system was circling around availability practically of components and products, and be able to complete it with off-the-shelf components, because everything what we needed to do should be directly available. Also made to point out the question we got from the government, I think I didn't tell, was to build and develop or to develop and build the Demcare ventilator within a couple of weeks, to be exactly within 3 weeks, and to produce in the weeks after that 500 complete systems to be able to deliver them to the Dutch market and to the Dutch hospitals. So we started with sketching that system, and on day 1 we started with a team of 50 people only from the development side, and that the timelines were pretty easily, because 1 week later we had a first prototype available. That's the one you see in the third picture. Then a week later we started to have the first prototype available in the hospital to be able to do technical tests in the hospital labs. And a week later again, so that's 21 days after the start of the project, we were able to already test really in a clinical situation on a real patient. And again, 1 or 2 weeks, let's say 2 weeks later, we completely arranged the CE exemption to be able to deliver the device to the market as long as there was the COVID situation. So we were able to deliver as long as the pandemic holds. Well, in parallel, we needed to ramp up production. And that production was, we were in a kind of lucky situation because we are here located in Eindhoven. And in Eindhoven, we just entered a new building because we expected some growth already. Not related, by the way, to the Demcare production, but that was the, let's say, lucky situation. And we started arranging resources directly at day 1. So the ramp up of production was completely in parallel with the ramp up of the development of the complete Demcare system. So we arranged the resources. We arranged 1 week later, when the first bomb was available, we started the procurement process and started ordering all materials already on a, let's say, preliminary bomb. And a week later, the bill of material of the Demcare was completed, and then we sourced all those components. A week later, we started the production, and 60 days after the start of the project, we had 500 pieces completely ready to be delivered. Well, there were a lot of interesting problems which happened in that period. First of all, it was component sourcing, of course. As said already, we needed to produce and to develop with off-the-shelf components only, but there were already limitations at that moment in the complete chain. So the first question was how to get all those components out of the chain. We were in a lucky situation here in the Eindhoven area where we produced the system, that we've got a lot of suppliers pretty close to us. And we were also in a lucky situation that those suppliers had at that moment a little bit trouble with their running projects, as a lot of things in that COVID period were a little bit slowed down. So a lot of those suppliers, they were able to collaborate with us and directly supply what we need. So from milling and drilling parts and all kind of things, we were able to directly get it from them. As said, we designed only from what is available on stock. So in the design phase, we discussed with the suppliers directly, is it available and can we move on with these components, or should we go to an alternative because it's not available? So we eliminated all kind of blocking items already up front, as we know that it was not available. We put it also our engineers, and I think that's also one of the key success factors. Our engineers were placed directly at the supplier. So, for example, we worked a lot together with VDL, one of the big companies here in the Eindhoven area in the Netherlands. And our mechanical engineers were located over there to discuss which production methods do you have available, and how can you easily make, for example, the covers of our system, that we are not going to design something really nice, which was not possible to create on the short term. And one of the things we also did was do not take no for an answer. Everything we did, we just pushed on the complete chain as much as possible. To make it possible. So we only stopped when we received a yes. And I think, in all honesty, that will not work anymore at this moment, because the pandemic really helped in this in this complete process, because everybody was focused on what happened in the pandemic and was really willing to help. Well, of course, we needed a lot of personnel and good trained personnel at that moment. And well, we again here we were in a kind of like a situation that there were old DEMCON employees which were able to get back to our production facility. So we had to ramp up 2 productions practically in parallel. We have one production facility in the eastern part of the Netherlands, which was producing our respiratory modules. And the production of that respiratory module was also ramped up extremely. And in parallel, we do in Eindhoven, we did build the Demcare system where we needed complete new personnel. And again, here we work together with also suppliers from the direct area. And we asked them, can you please hand over some qualified personnel to help us building that? And what we also did is that we used operators which were practically too high qualified. And that had one enormous advantage, that we did not have a lot of training time, and those guys were perfectly able to, well, self-start. And they grabbed a work instruction and simply started producing the system. And our backbone of own people helped us extremely, because as said, at that moment, I think we were with 800-900 people within the DEMCON group. And all our own people, our own backbone was able to help in the production process as well, and the development. Well, we had to scale up the lines, as said. So we were producing with one line for the respiratory module in Enschede, our headquarter location. We ramped that up to 6 lines of production in parallel. And here and we had a lucky location in that location, that we had a complete new building up and running. That's the bottom picture you see, our DEMCON Technology Center, which is our complete new assembly facility. And that one was just delivered before the COVID situation hit. So we were able to grab some free space over there and ramp up our production lines. And here in Eindhoven, we also had a recent new building with a kind of empty halls. So over there, we were also able to completely build up a new and streamlined production line for the Demcare system at all. And we were able, and that's to postpone other running projects. As said, we are with 800 people and running as a complete company, more or less between 50 and 100 projects in parallel. And we had a relationship with all our customers that we were able to postpone the other jobs we needed to do. And everybody understood that we were reallocating our resources to be able to build those machines. Well, the COVID measures was also a challenge at that moment, because we completely rearranged the facilities in our building as such that teams were not completely meeting. So and let's say literally touching each other. I think everybody can imagine that if you're ramping up such development and production, that the 1.5 meter distance rules and that kind of things were, well, not always taken that strictly because it was simply not possible. And as we knew that, we also really split the teams. So we had a restaurant, for example, for our production guys, and we have a separate restaurant in a different location where we really had the development team. The development team was not able to come into the production lines, and completely separated those locations. And the same happened in our production lines in our headquarters where we produced our respiratory module. All those teams have separate rooms where they can work with their own toilets and their own restaurants and all own everything. And the handover between teams which were working on the same line, so we produced in 2 shifts. Those transfers were done by paper or digitally. That also those teams will not meet each other to, well, reduce on all sides the face-to-face contact and the potential problem of infecting each other. And I think, in all honesty, also the pandemic helped in our complete system development, because I think everybody had one common goal. It was for everybody crystal clear what was going to be developed. As well, I showed the sketches in the beginning. That sketches became complete reality in the end, and nobody discussed on what we were going to develop. There was an extreme focus, and everybody was also extremely motivated in this whole challenge developing this, because everybody was aware that if the COVID situation became really even worse, that those devices were needed, and everybody had the feeling that they can really add something to the medical field in this case, and also everybody was extremely willing to help, from suppliers to customers. Everybody helped us to become in a situation to make this happen. So at the moment that we call the customer and they slow down their project, if we call a supplier, they stop producing for whatever kind of customer and they started producing for us. We even had situations for one component, just as a funny example. We needed one loudspeaker for the system. It is a product, an off-the-shelf product coming from the US, and there were hardly any on stock. So we simply placed an order, and they said, "Yeah, well, you can get it in 6 to 8 weeks," which was, of course, too slow for us. And then we just gave those guys a call, and we explained what we were going to do and what the rushy situation was. So I was in direct contact, for example, with the production manager of the plant over there, and he said, "Oh, that's nice. Then we will change the order of production, and tomorrow morning we will produce your speakers and ship it directly. And 3 days later we have everything in stock." That's of course a brilliant situation, but I think it will not work in normal times like this anymore. And then there was also really a special situation around certification. Of course, there were the CE certification was, let's say, chopped into 2 things. So there was a CE exemption first. We were ready in 6 weeks with the CE exemption certification part. So the development of the system we did completely according to the rules. It's developed according to normal medical at that moment the MDD, and we had also extremely short lines with the DECRA, our notifying body. So we had also discussions on a kind of daily basis, making the balance for what shall we do, what is needed on the documentation side, on the test side, and due to those extreme short lines, we were perfectly able to, not cut the corner, but take the corner a little bit more sharp, and do exactly what is needed instead of doing something and going to a certification or to the notified body, and they say, "Well, it's nice, but you also need to do this and that." We changed that order, and up front we were perfectly able to decide what to do, as we knew that those guys already agreed with the way of approach. And what we also did in the certification part is that the devices, after they were produced, we gave them an upgrade and created a complete CE in 4 months later. So I didn't deal with the Dutch government that the machines were more worthful for them if they have a full CE. So also the DECRA was highly involved in creating the necessary steps to upgrade all those machines from a CE exemption to a complete certified system. I think this is, from our perspective, the most important what happened in this period, and it's what we call the extreme partnering. So what we did, we have the short lines on the upper side from DEMCON to the DECRA to as a certifying or the notifying body. We had extreme short lines with 3 hospitals. We developed our system with those 3 hospitals together. So in the first days of the development, we already had a couple of doctors here on site, even that they were busy in the COVID situation, but they came here internally to discuss with us what is the exact requirement on the system, what need to be in, and what kind of stuff you can keep out to really keep a simple system which is perfectly able to be used in the COVID situation. And on the top side, you see the Ministry of Health, which is practically our customer. So the triangle between DEMCON on our side, the notifying body, the customer, and the end user, I think was an extreme nice situation on such a short lines to collaborate with each other and to be able to exactly know what you need to make on the other on one side, if it was going to be approved on the other side, and that already the end customer, the ministry, was happy in that situation as well. And on the bottom side of the sheet, you see a selection of all the partners who were at that moment able to ramp up their production and their delivery as well. Because without those partners, we were simply not able to manage what we did in this in this period, as we needed such an amount of stuff. Well, we cannot do that on our own. That's what I wanted to share with you. Thanks for your interest. Are there any questions?
Thank you so much, Ben. I think it was a very, very interesting story. And there was a question from the audience. And I would like to add a little bit to this question, that from the early production to the you produced in 8 weeks the first pilot, and what type of development method have you used? But what I would like to ask also and add to this, how much would be in normal time this 8-week development time?
Yeah, so practically we had a development time of only 4 weeks or 3 weeks actually, because after 3 weeks we went already on the patient. Normally, it's a good question. Well, let's first get back to the question: what kind of development method? We always use the same development methods here within our engineering company. We use a V-cycle and a kind of phased model. So we start with feasibility phase, and then we create a prototype, and then we start industrialization of the whole machine. So we practically used all those development methods exactly equal to what we do in a regular process. Mm-hmm. Although I think the big difference was that all waiting times and challenges around that they were simply cut out of the process. So we did everything. Well, we did it lean and mean, and rapidly after each other. I think that was the main difference. And I think what was a big game changer in the development process as we do it normally and how we did it now is that it was, to be honest, a little bit more directive as we do it normally. So then in the normal project, you have more time to discuss with each other which kind of specifications come in, how should it look like, how should it act, and that kind of things that takes normally a lot of time. And to be honest, as time moves on in a regular project, the scope opens up a little bit as well, because you get new insights and you get new ideas, and then, well, all kind of things are nice to add. And we did now simply have no time to add things. So if an engineer on our site said, hey, I'd like to develop this because it's potentially nice, then the complete team said, well, it's really nice that you want to do that, but we kick it out because a couple of days later, what we literally said to each other, if we deliver later, it will cost lives. And so I think we used the regular process, although extreme short and with no time to open up the specification or the scope.
So, and then in normal times, that was 2-3 times as much time as now.
I think even longer. I think if we regularly develop a project, it will. We do develop a complete ventilation system for customers. It can take up to 1 to 2 years. But it's also
that's the important thing. That's the important thing. So let's say from 1 to 2 years to 8 to 10 weeks.
Yeah, and I think the main thing, of course, we used simple production methods. We used simple components, everything off the shelf. So it was not as small as it was able to. It was not as light as it was able to. So we did a lot of concessions in the look and feel. For example, we put a laptop on top of it because we simply had no time to integrate a nice screen. So on that side, on the design side, we did a lot of concessions which created the ability to be that fast. So it's
very
also
interesting story, Ben, and I would like to congratulate. I think this is what you've been doing is a best practice that could be promoted and used also by others.
Thank you.
So Ben, thank you so much. Ben will also be available in the Expo area in case any of you would have any questions. And now let's go further. And from the ventilators, let's move to the electrostatic spray systems and to the disinfection topic. And in this pilot, there will be 2 speakers, Llopart and Antonio Salis. Jan, who is responsible for sales at Tecnostatic, and he has a university background from the University of Barcelona, and he will introduce the session. And then afterwards, Antonio Salis, who is senior R&D project manager at engineering in Cagliari in Italy. And Antonio has been participated and is participating currently in several Horizon 2020 research projects, also Horizon Europe new proposals in the ICT and the industry, with a focus on cloud and edge computing, advanced analytics, and cybersecurity. And Antonio has prior to engineering worked on multiple software and integration projects, and he was working with companies like IBM and ST Microelectronics, Telecom Italia, Tiscali, and other companies. So now I would like to give the floor first to Jan to talk about the electrostatic spray system development case.
Hello everybody.
Hello, Jan.
Hello. So yeah, I can start. We can put the presentation in the screen so that everybody can follow. Perfect. Okay, so welcome to everybody. I'm going to talk about Tecnostatic, the electrostatic technology, and how Coversatil has helped us, how we have improved thanks to this project. Next slide, please. Okay, Tecnostatic is a company that manufactures different models of professional high-performance electrostatic sprayers for surface disinfection, designed for all kinds of sectors. Our patented wraparound electrostatic spray technology allows all surfaces and objects to be disinfected to be covered. They can also be applied on the electronic devices such as televisions, PCs, or anything. This innovative formula manages to improve the results thanks to total disinfection in a simple and fast way, allowing to save time and resources. At Coversatil, we have been able to develop an autonomous equipment with battery operation. The equipment we have designed is a backpack, where we have integrated all the necessary and optimized components, easy to handle by anyone. The applications that can be made with our TS-ME electrostatic spray backpack are intended for all kinds of sectors that we're going to present at the Digital Technopole, highlighting hospitals, ambulances, or operating rooms. All the objectives of the product have been achieved. Are team autonomy up to 3 hours of the electrostatic spray backpack. Team autonomy up to 3 hours. 360 degrees coverage of the applied product, any disinfectant we use. The correct drop size, which is very important. Constant electrostatic charge without losses. Ergonomic design and an optimal equipment weight for use. Next slide, please. Yeah, well, here we had a video. We won't be able to see it, I think, because well, it was a problem. It was really heavy. The presentation wasn't okay for this stream platform. So as you can see in the images on the right, we have two different sprayers: the normal sprayer and our electrostatic sprayer. We can see how we have our electrostatic sprayer achieves a total coverage of 360 degrees. We can see how the drops adhere to the surface like an attraction of the magnet. So you are just disinfecting in one position, and in the other side of the object you are spraying, we have a total coverage. Thanks to this, we achieve savings of the disinfectant product we're using. We have a greater range of disinfection. We don't need to distribute the product with a cloth. It's okay only with the electrostatic spray machine. And thanks to this, we prevent this possible cross-contamination provoked by using a cloth from a place to another one when we're disinfecting. Next slide, please. Tecnostatic has created a manufacturing process to adapt to emergency situations and to be able to respond quickly and efficiently. Material stock agreement with the supplier, agreement with the transport company, and training of workers agreement with the auxiliary company. Coversatil has modified our manufacturing system and has enabled us to increase production considerably. We have modified the manufacturing production of the gun casing. Previously, we could produce 100 units per month, and now 2,000 units per month. Our suppliers have adapted to a supply system, and in 48 hours, we have the components in our facilities. We have formed an assembly system. Previously, we could assemble 100 units per month, and now 2,000 units. We have trained personnel from external auxiliary companies and increased our assembly capacity. We currently have an initial stock to provide an immediate response to an emergency situation. The process of certification in compliance with European standards is currently underway. Our aim is to complete this process in the course of 2023. Next slide, please, Christian. Yeah, okay. Tecnostatic, in addition to having its own staff, has created a work team outside the company, giving training and have signed a commitment contract that in case of pandemic, this work team will join our company. These people have been trained in the different production processes. The commitment to join our company is verified every 6 months. Next slide, please. Regarding the production of the equipment, here we can see the configuration of both the inside of the backpack and the gun. A specific mold was designed to correctly create the application in the nozzle of the gun. Here we have another video. I think this one is possible to be shown. Yeah. So in this video, we can see in 3 dimensions the different components that make up the backpack of the electrostatic spray gun. Normally, this video was to be shown while I'm talking because it was inside the slide, but well, it's okay. You can make the idea of what the components are. Okay, so next slide, please. Yeah, regarding the coverage of the product, we continue doing different tests to check the range. These tests are being carried out with different disinfectant products. As you can see in these images, the quality in the left, the quality of the image looks like this because the particles have adhered in the camera due to the scope, the big scope of the disinfectant equipment. On the other hand, we have carried out other tests with other sensitive paper to water with our electrostatic system. And as you can see, well, with this test, it's shown how the sprayed liquid changes the tone when we apply it throughout the surface. Well, in the 4 images, I think you can make the idea of how the test is. Then next slide, please, Christian. Finally, as a conclusion, technologically, our spraying system, we think, is the most advanced system in the world for all the benefits it has that we have mentioned above, apart from many more. That if anyone is interested, we can, of course, have a meeting and a longer conversation. Belonging to Coversatil has helped us to create autonomous battery equipment without an electrical connection, which has been able to significantly optimize our technology and equipment. This has been accompanied by an improvement in costs and an increase in production capacity to be able to respond to demands in future critical situations. Hope we don't have to to respond to these demands, but in case of, we're prepared. Okay, next slide. So thank you very much to everyone listening, and if you have any questions, I will be glad to respond to you. Hello, Antonio. So your turn.
Okay. Good morning, everybody. I'm Antonio Salis. I'm a senior research project manager in the engineering group. Gabor said most of the things, so just not to the things that the engineering group is working currently on more or less 40 working research projects. And personally, I'm involved in 3 projects, Horizon 2020, and I started also an Horizon Europe research project. Today, I'm going to showcase the implementation of an augmented reality-based training that we developed the Coversatil project for the MS4, so the electrostatic sprayer system. We will show shortly a video that includes everything. But before starting the video, I'll recommend, I remind all attendees that there is an event chat on the right of your panel. So in case of a need, you can post questions or other stuff you need. So I think that we can start the video now. Thanks.
The COVID crisis posed a big challenge on manufacturers, asking for more medical devices and other tools, such as disinfectant spray systems. This has ended up with consequent requests for higher flexibility and fast response in production, and obviously on training needs to optimize the use of such devices. Manufacturing Setting 4 responds to these criticalities by acting on product features and supply chain resilience, and a novel technology has been developed. In this video we explain how the technical manuals and the 3D model created for the novel device have been used to build an augmented reality training tool to support the users on the best use of it. The Space One platform is a leading solution for extended reality technologies that support the use of AI, and has been used for the development of advanced training and remote collaboration, to demonstrate the support to junior technicians during maintenance, facilitating the collaboration and knowledge sharing, even remotely. The first screen shows the main menu, where the training tasks are managed with defined work orders. The 3D model of the spray device has been imported and splitted in an asset hierarchy, so different components can be searched and related manual items presented. Knowledge repository keeps all multimedia information that could be shared among the different users. Finally, the extended collaboration option enables different users to set up a remote session where the senior workers support the junior ones. The user has to define which device will use. It could be a tablet, a smartphone, or even a VR head-mounted display driven by voice commands. Work orders, so training tasks are assigned to the user. Here we can choose between training for MS4 and MS6. Choosing the backpack procedure, we step ahead with the dedicated procedure of the disinfectant sprayer. Here we have a description of the activity to carry out on the left, while a 3D model of the asset involved in the activity is shown on the right. The window on the right can be selected and a higher level of detail can be shown. We can view or hide different components of the 3D model. The full list of components is presented in one particular. The gun in the video has been selected. From the menu below we can select documents, thus showing documents related to the specific activity. Here we can see the spray technical manual. We can also select the video that presents recorded video related to the activity. So the presented video explains in detail the procedure to be used for the change of the backpack battery. This could be a better option for a junior user than reading the manual. Selecting images, some more details on specific components could be showcased, helping the user in the procedure. Once the specific operation has been completed, the user can move to the next step in the procedure. Here we have to connect the backpack battery. Again, images and videos can guide the user in the specific activity. At the end, the next operation can be started. Here we have to connect the fluid and air houses to the backpack power. In this case, the user can get more help navigating the 3D model, localizing the component, then proceeds opening the cap of the tank and pour the product. Again, the linked images can provide all details needed to guarantee the perfect execution of the activity. The 3D model can assist in every moment, zooming in or selecting specific components, for example the hose connector, to enable the user to complete all activities easily. From the top menu we can also select the knowledge repository and consult it for useful contents, for example images, videos, documents or other annotations related to the procedure can be checked. Here for example some videos are available for the users. So, to summarize, extended reality technologies have demonstrated to be an effective support for the advanced training, remote collaboration and knowledge sharing activities, which are key elements to be leveraged in case of crisis such as pandemics. The cloud is a technology that can boost the impact of such solutions, collecting and making available advanced applications, contents and knowledge everywhere on Earth. In the co-versatile project, the digital technopole is based on cloud and acts as an hub that provides all this expertise, and collect all lessons learned and join forces against COVID.
So, I think that this video has, let's say, summarized the potential of the Space One technology supporting the training even remotely of operators and technicians. So to boost the performance of people responding to emergency like COVID. Just few words finally, just to say that extended reality technology can obviously improve the performance in terms of training, making people spread around the world, joining forces and work together. So the senior worker, even remotely, can help the junior one on site. And well, the other point is the cloud that could be let's say the hub that collect and make available all the information to all interested parties. And in our project, the digital technopole played this exactly role. So in the next presentation, Sebastian will present the benefits coming from the digital technopole. Final word, the same approach of the technopole has been adopted also in another project that engineering is leading, called the Eureka. And I think that's all from my side. I thank you very much for your attention. And I know if there are questions, comments, I'm available.
Thank you, Jan. Thank you, Antonio. I think these were very interesting cases. And I do have one question that you mentioned that you are part of multiple projects, and you also explained the learnings from co-versatile. And how far do you intend to replicate the co-versatile learnings into other projects, or how do you see synergies with other projects or initiatives for co-versatile?
Good point. As mentioned before, in the Eureka project, we are adopting, let's say, a bit different approach. So we will trying to use the cloud, but also federating different clouds to merge contents, and so improve, let's say, the whole content that would be available to the interested parties. So let's say best way to joining forces against emergencies. That would be, so let's say cloud federation concept, let's say applied to emergency would be another booster, let's say.
Mm-hmm. Okay, thanks. And you also mentioned the digital technopole as a key platform to promote the results and to access all the tips and tricks and the resources that you were producing. About the digital technopole, we will hear a detailed presentation from 12 CET, so in approx 15 minutes. And now I would like to close this first part of the event, and we will have now approx 15 minutes break. Please be back on time at 12. We will start with we will continue with the digital technopole. So see you soon. Hello, welcome back after the break. And now this is our last section before the expo starts. And now we will hear a presentation about the digital technopole. The digital technopole has been already mentioned by Antonio, but also by the previous presentations. Which is an online one-stop shop for services, experts, softwares, case studies, and pilots, focusing on the topics relevant to co-versatile, so the topics around manufacturing resilience, adaptation in response to crisis. And the platform will be introduced by Sebastian Pena. Sebastian is a managing director and founder of clesgo, which is a startup working towards facilitating the democratization of digital solutions in the manufacturing industry. Prior founding clesgo, Sebastian worked with the ECI group in the position of domain lead geometry until January 2016. And he was also deputy head of the Computer Center Interactive Engineering Technologies at Fraunhofer IDG until September 2013. Sebastian has a very strong R&D background. His main research areas include cloud computing, machine learning, computational geometry, mechanical design, and robotic kinematics. Sebastian studied mechanical engineering and finalizing his PhD at the University of Technology of Darmstadt in Germany. He is member of several organizations like Eurographics, GI, ACM, and so on. And he has participated in multiple German and European projects, among others, just to mention a few, like Cloudy Factoring, DigitBrain, Pulsate, and CoVersatile. And within CoVersatile, Sebastian is leading the development of the digital technopole, the development of the whole concept, and also the implementation of the digital technopole. And with this introduction, I would like to give the floor to Sebastian. And Sebastian, welcome. The floor is yours, please.
Hi, Gabor. Thank you very much for a nice introduction, and good afternoon, everybody. So yeah, as Gabor was saying, we had hearing in the previous presentation, also started by Robert at the beginning about the digital technopole, and Antonio make a very nice a transition from his presentation to this one, and he was explaining what the digital technopole and why that plays an important role in, let's say, today's situation in the world. So let us talk a little bit more in details about the digital technopole. So yeah, we are facing a lot of changes right now, a lot of disruption, maybe the biggest one, or at least the one that we were not really considering, or we didn't have in mind, was the COVID-19 pandemic. But we have been facing several challenges before, and now are becoming more clear. For instance, the climate change and things like that. But what the big impact that the pandemic generated was that it actually demonstrated or showed us that we were not prepared as a society to respond to that. It could be that some governments will have some plans and things like that they could react to something, but we as a society, we were not prepared for that. And at that point in time, we also part of, we decided to create the CoVersatile also because of that, because at the beginning of the pandemic, we also saw that, we needed to do something, but we didn't know how. And we knew that people were willing and wanted to be active and be part of the solution, but it was very difficult to coordinate, to find other peers to work with, or to see how you can help somebody else. At least if you are talking from a business perspective. From a personal perspective, many people got engaged, and we're trying to help others in different activities, but from a business perspective, was a little bit difficult. So that is one of the main motivations that we have in CoVersatile, and specifically for the manufacturing industry, to understand how we together can be better prepared as an industry to master, to solve these difficulties that we are going to face, that we are facing, and that we are going to face in the future. And because of that, we said, okay, we need to do something. And the way of doing that is, we know a lot of experts, we know manufacturing companies, but how to bring them together. So just to share some experience, some personal experience that I had. So we are located in Germany, in Baden-Württemberg, in Stuttgart. And at the beginning of the pandemic, some manufacturing companies start saying, well, we have a production facility. We would like to help in doing some mask or something like that, for instance. And I remember that at that point in time, the regional government tried to set up a website where people could offer something, and others could also benefit from that, something that somebody else would offer, but was just very static. That was not coordinated. It was just what people could do at that point in time. And we were trying to understand, okay, how can we bring these together? How can we bring experts in manufacturing? Both are having that idea in mind. They want to be part of the solution. They want to help. They want to help mastering the challenges that we are having. So how can we achieve that? And because of that, we start thinking about, okay, we need something. We need a platform where we have all together with a concrete common mindset, where we said we want to be part of the solution and we want to contribute when this is needed. Very specifically, we are talking about ICT solutions, digital technologies, new business model, digital business model, and how that could help manufacturing companies. So that's where we said, okay, we want to have this platform where we have all this expertise on the one hand, this network of experts, and on the other hand, we have manufacturing companies who would like to get some support to solve some challenges or to adapt or to change some of the production facilities or the production conditions that they have in order to contribute to some part of the solution of the pandemic, or also to reinforce and strengthen what they are doing so that they can also survive during these critical situations. So that's what we decided to do. We want to create this platform. We want to bring, to set up this mindset. We want to bring the experts, and we want to help everybody to connect and to start working with one another. So if we consider a little bit, who are we addressing here? We have three main different target audiences, if you want. So the first one is about who will benefit about, well, the first audience who could benefit about what we are representing through the digital technopole are the manufacturing end users. As I was saying before, many manufacturing end users were challenged by this COVID situation. We have disrupted logistics. We were not finding, or the manufacturing companies were not finding the proper material, the raw material for their productions, or the demand for what they were doing was not that high at that moment, or because of remote work, they couldn't work directly on premise, but they starting to do remote work, and for some of them that was difficult. So it was challenges. It was a shock for everybody. So one of the first benefits for a manufacturing end user is actually to have the possibility to start talking, to get connected to experts that could understand them, what kind of challenge they are going through, and based on that, try to define what kind of solution could help them. So that's one of the first benefits for manufacturing end users. The other benefit is that since we are building this network of experts, those experts are providing solutions. They are providing their expertise. So one of the things that an end user could do is they can explore, they can find, and they can actually get access to those services, either directly through the platform or directly by communicating to the experts. And finally, it is not only about bringing experts and end user, it is also about building that community of experts and users, and create that space where they can communicate, interact, and share information from each other. And very important to learn from the experience that everybody is having, because sometimes there are companies who are going through a process, they successfully master or overcome that challenge, and they could also help somebody else who are experiencing a similar situation. So learning this collective intelligence play an important role in today's world from our point of view. So now let us move to the next target audience that we have, and those are the manufacturers and the ICT experts. So as I was saying before, with the personal experience, many companies, when the pandemic started, we were the ones that we are here in Versatile. We were one of them. We were saying, okay, how can we now support with the technology, with the expertise that we have? How can we be part of this solution? How can we make something that help the society to overcome this pandemic. So the Digital Technopole is actually bringing is that vehicle that will support you, that will allow you, that it will enable you to actually help help other manufacturers, and in general helping in strengthening that the manufacturing industry become more resilient. So that's an important aspect. Resiliency is very important in today's work conditions, where it is not only about the demand, the end user, the customers, what they believe, what they want to have, but it is also about how the macro, conditions in the world are somehow also generating impact on a very lower or a very narrow level to any one of us. Additionally, so since we are building that network, one of the benefits for those experts is that they will be able to access more end user who could benefit from the expertise that they have. So we know everybody has their own network, they participate in some events. Nonetheless, those events or those networks are either very close to your regional, so are geographically defined, or depends on the topics that you have, and then you go always to similar, let's say, fairs or to similar events, but all have a similar topic or a similar scope. And because of that, the people that you are finding or meeting is more or less the same, or they are all in the same context. And one of the benefits that they will perceive by joining the Digital Technopole is that they are actually going to access and to promote and to show the expertise and the solution that they have to a wider audience that is coming also from different regions and from different thematic scopes, if you want to say in that way. And finally, they will have the possibility to assist and support every individual user or any individual manufacturer in solving their individual challenges. And I guess that this is one of the most important aspects, which is how we can become part of the solution as an expert and with the expertise that I have to offer. And finally, another very important target audience that we have are the digital innovation hubs. So the digital innovation hubs are becoming very fundamental and very relevant for the industry today. And one of the reasons is that, well, sometimes it is difficult to bring together, to talk the same language when we are bringing experts and manufacturing or end users together. So the digital innovation hubs in the context of manufacturing are playing that important role, where they are somehow in the middle with their expertise, moderating and helping the end users and the experts to work together, to get together, to understand each other so that they can solve the solution. And there is where we see some benefits for them as well. So on the one hand, the DIHs could definitely be part of making rapid response a reality for the manufacturing industry. So we see that at the beginning of the pandemic, that was a little bit difficult. We have seen the example of DEMCON, that they were able to, in a very fast manner, deliver these ventilators. Nonetheless, this is an exception, not the rule. And the capacity in manufacturing is much higher than that. But not everybody had that, let's say, flexibility and that mindset to those changes. And actually, digital innovation hubs could play a very important role there. Finally, or in addition to that, they can also facilitate that those manufacturing or those communication, that connection, that collaboration that is being built is as successful as possible. And finally, the digital innovation hubs normally are located in regions. They have a network of end user and experts. And by joining and being part of the Digital Technopole, one additional benefit that they will have is that they will increase the pool of experts that the network could benefit from. So those are, let's say, some benefits from these different target audiences. Nonetheless, at a very high level, but very impactful if they see it and if they join the Digital Technopole in the way we imagine. So we have been talking about the Digital Technopole, but what is the Digital Technopole actually about? So the Digital Technopole it is a B2B platform. So we are talking about relationship between businesses. So we are not expecting to directly help some citizens. We are expecting to help other businesses, and then those businesses, with what they are doing, could help the society at large. But the Digital Technopole, at the end of the day, is based on the concept of agora. Agora is a Greek word that means bringing together the community and the market, or the marketplace, and this is actually what we want to achieve. It is not only about making technology accessible, but it's also about building trust, building understanding, and helping the end users to understand and to learn how they can actually use and benefit from those kind of technologies. And from that perspective, we have in the community part, we have the people, we have the digital innovation hubs, the manufacturing companies, the different experts, and they are working together within that, working and collaborating together. And they also need a space to communicate, to exchange information, to interact with one another, because they need to learn and they need to foster that collective intelligence. And when we talk about the marketplace, then we are talking about, or we are referring to the different services that the different experts are able to offer to support the end user in their process. So by bringing them together, we are somehow generating a more holistic view on how this technology works. We are not only talking about, okay, make technology accessible or more democratic. We are also talking about how the community could increase, could be cultivated, could benefit from the experience that each is having, and at the end of the day, being stronger together and being more resilient together. So in order to achieve that, we have different features. We have dedicated features for the community and also dedicated features for the marketplace. We will have a tour in a few minutes. So from the community point of view, we have three main interactions. One is the possibility to share your content, to share your experiences, your success stories, your best practices. The other one is the possibility to discuss within a panel your challenges, or to share your expertise with one another and help some of the people understanding how they could benefit from the solution that perhaps you are providing. And finally, and a very important one, is how to get support, direct support from an expert. And then we develop a concept which is motivated by the idea of call for solutions. And what you do as an end user is that you start a call for solutions where you describe your challenge. And then internally, this challenge is matched to different experts. And then those experts could propose you a solution, and you can start interacting and communicating and understanding how that expert could support you in solving the challenge. And when we look at the marketplace, we are currently focusing in three main areas. One is software solutions, software applications. Some of them are cloudified, some of them are not cloudified, but the idea is how to make those software solutions available to the manufacturing industry. Also, training is very important training courses so that people are able to understand how they can use those solutions, or how can they apply the knowledge that they have in their specific settings and environment. And finally, we have the consultancy, where we try to enable that a client and an expert, or a manufacturing user and an expert, could start a project and go through a process, through a consultancy process. And that consultancy process is supported by different, let's say, features organized as a project, where you can share information in a transparent way and communicate within the team that is running that consulting process, so that at the end of the day, everybody is on board, know what is happening about, and can contribute to that. So that was more or less the idea behind the Digital Technopole and how it works, and the functionality, or the main functionality behind that, and why we are doing that in that way. Now, let us make a tour of the Digital Technopole today. So I guess that you should have seen, let me just verify that. link, I guess, or otherwise you will receive a link so that you can also see it by your own. In any case, this is the link. This is a live running platform, and you can sign up for that. So if you have an account, you can log in yourself. Otherwise, you can sign up. In my case, oops, sorry for that. I have an account, so just let me rapidly log in. So after you log in, then you have, as I was explaining before, two main areas, the community and the marketplace. So if we are talking about the marketplace, then we're looking about or referring to the services that different experts are offering and are making available for the manufacturing and users. So you can either, if you know the partner, you can look for the partner that you know, and then, for instance, see the solutions that they are providing. If you don't have a partner, or if you are more interested in a specific sector or in a specific technique, then you can go to the specific technique and then see what are the different solutions that are being offered for this technique. Otherwise, the other aspects that you can do is that you go by category. You can go to the software applications and just look to the description of the applications, look at different informations. For instance, here a manual describing how to use that tool, or for instance, in this case as well, going directly to the tool and start using it. But this is just from the point of view of the marketplace, and this is a very short introduction. But the other very important aspects is from the point of view of the community. So imagine that you are trying to look for a solution, but either you are not sure about or you didn't find exactly what you are looking for. So the other option that you have is you go to the community area and then you try to see what other users has shared about the information or the similar challenges that you have. So imagine here we talk, and we have seen it today, the disinfection system. Now imagine that you want to hear more or understand better how that disinfection system was created and how they solved the challenges that they were having. And then you can read some information about that and perhaps engage with the authors and with other members of the community in understanding that better, how this system was being developed and how they solve the challenges that they have. Or on the other hand, you can also go to a panel, engage in a panel discussion, and start sharing or commenting, either you providing your point of view or you asking questions so that you get the support. And finally, if you still don't find what you want or what you are looking for, finally what you can do is that you can start a match, which, as I was saying before, is based on the concept of call for solutions. So you create a match, you start describing the match, what is the context of what you want or the challenge that you want to solve, what is your objective. If you have some conditions, some sub-requirement, you describe them, then you send the match, you start a match, and we, or the platform internally, try to recognize who can help you in solving that solution, and then the experts are being made aware of that specific match, and they will be able to start responding with a solution and start interacting with you in an individual manner. So that was, in a rapid way, what I wanted to present about the Digital Technopole today. I encourage you to join, to be part of this new mindset that we are developing, to be part of the solution that we want to achieve, to be part of making the manufacturing industry more resilient, and to be very prepared for this kind of crisis, and to achieve that rapid response is actually a reality for the manufacturing industry as well. So please join the Digital Technopole, and if you have any question, I will be more than happy to answer them.
Thank you, Sebastian. Yes, there are some questions from the audience. In the meantime, if it is possible to present again slide number 12, where we could see the link to join the Digital Technopole, I think that would be great. Yes, thank you. Just to make sure that this is visible here while we are talking. And the first question was about the Digital Technopole, about how to join it. I think that Sebastian, what you mentioned, the partnering is a key challenge in Europe. I think that we have seen this also from the DEMCON case, what they called extreme partnering, and that partnerships are really important, and the trust what you mentioned is very important. And I think in Europe this is an area where we need to improve. And I think here the Digital Technopole could play a very important role. And so, how do you see for the free type of stakeholders you mentioned, how to join the Digital Technopole, and what would be your position for that?
Yeah, thank you for the question, Gabor, and for recollecting what I was presenting. I definitely agree with all what you were saying. This partnering, this connecting people, bringing together expert and user is key in today's technology, in today's world. Things are evolving too fast, and only we together with a different perspective and the different knowledge that everybody has, we are together able to do that. Individually is much more challenging and much more difficult. So the Digital Technopole, we try to lower the barriers as much as possible. So for the time being, and we want to keep it as long as possible, there is no subscription price, there is no fee, there is nothing like that. Everybody can join the Digital Technopole. The only thing that you need to understand is that this is a B2B platform. So we are expecting that if you join the Digital Technopole, then there is a legal entity behind that, and the legal entity is part of the Digital Technopole, because at the end of the day, the agreement or the relationship between these parties we were referring to are business parties. So that is one of the important aspects. But after you join the Digital Technopole, then you will have access to all the functionality. There are no restrictions. Maybe the only difference that we have currently is that if you want to also, if you are an expert and you want to be able to offer your services and your expertise, you will need to request to be approved as a service provider or as an expert. And that is something that we are doing manually at the moment. That means that there is a button when you register your legal entity where you just click and you make the request. And based on that request, then we start analyzing. We might contact you back and ask you some questions, because we want to make sure that whoever is providing the services know about what they are doing. They have some experience on what they are doing, and they are really going to help the people with good quality. Because of that, that's the only, let's say, real check that we are doing if you want to become a provider. Otherwise, we want to have as lower barriers as possible so that everybody can benefit from this.
Thank you. And there is another question also. If someone goes to the Digital Technopole and finds a solution, then what is the next step? How to use that? How to build upon that?
Yeah, that's also a very important one. So we have experience with these kind of platforms, and in a normal situation or normal condition, let's say, we were always thinking about reducing the legal aspects, or not reducing, but facilitating that some of the legal aspect for the end user as minimal as possible. So we were considering, for instance, having just one single phase, one single partner, which is actually the one offering you all the services and all the technology or all the expertise that such a platform has to offer. Nonetheless, in the case of the Digital Technopole, we needed to have a different approach, because we wanted to have a rapid provision of solution, a rapid availability of the expertise that different partners can offer, and easy access to that. And because of that, in the Digital Technopole, we are following a different approach or a different path. And that path means that at the end of the day, is every single service provider the one who is providing you the service. And there are different ways to provide you the service. If that service could be accessed through the cloud, for instance, then you will be able to access that service through the platform, or you will get the links to access the service to the platform. Or if it is a training course and that training course is available in the platform, then you will access that training course in the platform directly. Nonetheless, if there is a service which is, let's say, it has a different infrastructure, or is a physical service, or requires some external infrastructure that the platform doesn't support, then what is going to happen is that you contact, or you will get, after you select the service that you want to have, you will have the possibility to get in contact with the expert, and then you start having a bilateral conversation about how you need to get, or what you need to do to get access to the service, and what are the conditions for that. So at the end of the day, it's as flexible as possible from every side. So from the service provider point of view, as well as from the manufacturing and user point of view.
Okay, thank you, Sebastian, for the answers, and thank you for the presentation. So please register for the Digital Technopole, and in case you have any questions, Sebastian will be available over the booth of the Expo from 2 p.m. to 5 CET today. And if we could go back to the agenda for the afternoon, I would like to have a few words about the schedule for the afternoon. At the Expo area, you will be able to meet our experts, and they are happy to consult you on specific issues such as the resilient supply chain, the creation of products and processes, the workforce ramp up, and agile manufacturing and cloudified services. Yes, this is this slide exactly, and this is where where you can see all the booths for the Expo part. So in case you are either a manufacturing company or somebody who has a solution who would like to sell this to the manufacturing SMEs, or if you are an intermediary, a DIH, or any similar entity, then you can have meaningful discussions in smaller groups on the specific topics, on the free cases which were presented, the silicon mask, the electrostatic spray, and the disinfection, and also for the ventilator production and how to ramp up that. But on top of that, you will see also other topics like the supply chain resilience, like certification and product processes, workforce ramp up, and so on. So I think it's really a very good opportunity to talk to these outstanding experts. Well, as we discussed, Co-Versatile, one of our mission is to connect the European manufacturing industry. So connect you now with the consortium members and provide you ready solutions or almost ready solutions. And so, of course, you can do this in the afternoon at the Expo area, but you can also continue doing so via the Digital Technopole, as mentioned, and we can get in touch and can offer to you one-on-one consultation in order to find tailored solutions to your specific requirements. So with this, I would like to thank to all the presenters, to all Co-Versatile partners, and to all of the participants of today's conference for the attention, for the questions. And now I would like to close the morning part, and now we are going to have a lunch break, and we will have the Expo starting at 2 p.m. CET. We welcome you back at 2 then. Thank you and bye. Have a great further day.